Hi folks. Okay, well, it's a pretty large crowd out here and it's my first talk, so please bear with me. So today I'm going to talk about pgcopydb, which is basically pgdump and pgrestore on steroids, which is basically like opposite of me. Okay, so moving on to the problem statement, right? We basically want to copy our database. So the most simplest query which you can think of is create database blah 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 with template, right? But of course, you can't move between different servers. You can't move between versions, right? So the next logical thing you can do is you can use pgdump and pipe it to pgrestore. Well, it's a pretty long stage. Let me walk there. So the -fc is basically a format which pgrestore can understand. So you can just ignore that. But this is pretty slow, right? So the need for speed. So you can introduce parallelism with -- jobs in, right? But that's a problem here. You can either stream, which is pipe, or you can choose to go with parallelism, right? So you can either choose between streaming or you can use parallelism. So here is presenting pgcopydb, right? So it's a fully open source tool which is written by Dimitri, right? And you can migrate or copy your databases between servers using the single command, pgcopydb clone. Then you can also mention the jobs and stuff, right? So the pretty cool stuff about this is, one thing, you can bypass those intermediate files which you need to do, like if you're using pgdump and restore with jobs, right? And you also have support for same table parallelism. So like it basically splits the tables by like city ID and stuff, right? And we also have online migrations, which is change data capture mode. So here are the 10 steps, right? So we still use pgcopy, so we still use pgdump and restore for the schema parts of the migration, right? Then we also query the catalogs, and we also have filtering methods, which means that you can choose to migrate certain schemas, certain DB, certain tables, etc. And so first we restore the pre-data parts of the migration, which is basically create table and stuff. Then we have all these like auxiliary processes, which will, so we use the copy protocol for actually migrating the data from source to target. Then we have these auxiliary processes for migrating the large objects, creating indexes, installing primary keys, and yeah, and we need to also sync the sequences because it gets like reset. And we also have the post data schema part, which is basically creating the views, materialized views and stuff. And also, I want to end with this pretty cool trick from pgcopydb. So when you want to like install a primary key, right? So like it basically has this thing, alt table, add constraint, blah, blah, blah. So this actually takes this access shared exclusive lock, which basically means that you can't have concurrency when you're building indexes on the same table. So what pgcopy does is that like it breaks that command into two, which is basically like it creates this unique index. Then it has this alt table. Using this index, like it creates the constraint, which means that you can achieve a higher degree of parallelism than you normally would. That's it. Thank you.